Right now, nearly 1 billion miles away, there is a planet wearing a crown of ice that hides what it actually is. From Earth, Saturn gives the illusion of absolute stillness, wrapped in rings, turning slowly in the void, untouchable and serene. For thousands of years, that is the planet we believed in. We were wrong about almost all of it. In 1997, we sent a 6-ton machine to find out what Saturn really is. We called it Cassini. We loaded it with cameras, gave it a nuclear heart, and fired it across 1 billion miles of empty space to become our eyes inside the storm. For 13 years, it wove through a graveyard of pulverized moons, listened to the planet breathe, and watched perfect geometry rage at the pole. Then it found something nobody at NASA had planned for: a warm, salty ocean hiding in the dark. Hydrothermal vents, the exact ingredients required to grow life, sealed inside the ice of a moon at the edge of the solar system. And on September 15th, 2017, NASA executed our own machine. They commanded it to dive into Saturn at 77,000 miles per hour and burn until there was nothing left to send. They had to kill the only witness to protect what it found. Let's begin. There is a danger in looking at things from too far away. Distance removes the violence. From Earth, Saturn is a mathematical triumph. It is the 6th planet from the Sun, a golden sphere turning quietly in the black. But when you cross the 1 billion miles of empty space between our world and Saturn, the poetry evaporates. Saturn is not a world you can stand on. There is no surface, no solid ground to plant a flag or build a colony. It is a gas giant, a bottomless ocean of hydrogen and helium, held together by a gravity well so immense it warps the space around it. Saturn is enormous. If you were to take the Earth, our entire world, all our oceans, all our continents, everyone who has ever lived, you could drop it into Saturn and it would vanish. You could drop 700 Earths into its interior and the planet would still not be full. And that massive volume is not sitting still. It is roaring. Look at the surface. It appears to be painted with perfectly smooth horizontal stripes of gold and white. But those aren't painted lines. They are jet streams. On Earth, a Category 5 hurricane, the most destructive weather event our planet can produce, has wind speeds of around 150 miles per hour. It can level cities and tear the bark off trees. On Saturn, the equatorial winds blow at 1,100 miles per hour. Winds so unfathomably fast, they smear the ammonia ice clouds into continuous, never-ending bands. A permanent, planet-wide hurricane that has been raging since the birth of the solar system. And beneath those clouds, it only gets worse. If you were to fall through the upper atmosphere, the pressure would begin to rise. The sky would turn from pale yellow to deep orange to pitch black. The gas around you would become so densely packed by gravity that it behaves like a liquid. Deeper still, the hydrogen is crushed so violently that its electrons are squeezed out it becomes a metal, an ocean of liquid metallic hydrogen conducting massive electrical currents and generating a magnetosphere nearly 600 times larger than Earth's. And that magnetic field has a voice. Because the planet is so massive, the magnetosphere acts like a cosmic radio transmitter. It catches the solar wind, accelerates the charged particles, and blasts out intense, sweeping radio waves into the void. When Cassini captured those frequencies and translated them into audio humans could hear, it didn't sound like wind. It sounded like a siren, a synthetic, rhythmic alien wailing echoing out into the absolute dark. It is the literal sound of a monster breathing in the vacuum of space. It is a nightmare wearing a halo. For most of human history, we kept our distance. We looked at the jewel through telescopes, safe behind our own atmosphere. But in 1997, we decided that looking was no longer enough. We built ourselves a pair of eyes, a nearly 6-ton piece of human engineering named Cassini. We packed it with cameras, strapped it to a Titan IV rocket, and fired it into the dark. Through Cassini, we would finally cross the billion miles of empty space. Through Cassini, we would see the storm up close. It was a one-way ticket. Cassini was not built to come home. It was built to orbit the gas giant, map its storms, and survive the radiation for as long as its nuclear battery would allow. But to study Saturn, our eyes couldn't just orbit the planet. We had to navigate the graveyard. The rings of Saturn are the most famous optical illusion in the universe. When you look at them from afar, they look solid. A perfectly flat, glowing track circling the planet's equator. But nature does not build racetracks. The rings are a crime scene, a physical record of extreme orbital violence. Millions of years ago, Saturn likely caught something in the dark, a wandering comet, an asteroid, or perhaps an entire moon of ice and rock. But whatever it was, it made a mistake. It drifted too close. It crossed an invisible mathematical boundary called the Roche limit. This is the exact distance where the gravitational pull of the planet on the near side of the object becomes stronger than the gravity holding it together. Saturn didn't just pull it in, it dismantled it. It ripped the object to pieces. The ice and rock shattered, stretching out along the orbital path, condemned to circle the giant forever. When we arrived, we did not find a solid track. We found a blizzard of shrapnel. Billions of fragments of dirty ice, some as small as grains of sand, some the size of houses, some the size of mountains. And if you could stand inside that storm, you would not see beauty. You would see them orbiting past you at 40,000 miles per hour, a hypervelocity hailstorm, constantly colliding, grinding, fracturing, every collision fast enough to vaporize anything in its path. But the most unsettling thing about the graveyard is its geometry. The main rings of Saturn stretch out across 170,000 miles of space. That is wide enough to fit the entire distance between the Earth and our moon. But they are not deep. Despite being hundreds of thousands of miles wide, the rings are, on average, only 30 feet thick, 2 stories tall. If you could approach the rings edge-on, the entire structure would vanish at the last second. A sheet of pulverized ice the size of a solar system, hiding in 2 dimensions. And within that impossibly thin sheet, there are ghosts. When we looked closely at the rings, we saw massive dark streaks forming and disappearing across the ice. We called them spokes. They are shadows the size of Earth, rolling against the current of the rings, vanishing into the dark. They aren't physical objects. They are electrostatic storms, microscopic particles of dust suddenly charged by the sun's solar wind, or lightning deep within the planet, lifting up and levitating above the icy boulders, casting massive ghostly shadows across the graveyard before losing their charge and falling back into the dark. For over a decade, we threaded the needle. We flew our proxy above the rings, below the rings, and sometimes, terrifyingly, straight through the gaps. A machine dodging mountain-sized bullets in the dark. But the rings were not the only things hiding in Saturn's shadow. Saturn is not just a planet. It is a miniature solar system. It drags an entourage of over 100 moons through the dark. And as we turned our cameras away from the rings, we found worlds that defied everything we thought we knew. We looked at Titan. Titan is the second largest moon in the solar system. It is larger than the planet Mercury. But it doesn't look like a moon. It looks like a toxic, frozen mirror image of Earth. It is the only moon in our solar system with a thick, dense atmosphere, a suffocating haze of nitrogen and methane. When we dropped a probe through that haze, the images it sent back were terrifying. Titan has weather. It has clouds. It has rivers and massive dark lakes. But at minus 290 degrees Fahrenheit, water is frozen harder than granite. The rivers and lakes on Titan are not water. They are liquid methane and ethane. It is a world where it rains rocket fuel onto beaches made of frozen water ice. A dark, toxic echo of our own planet, suspended in deep freeze. We know what it looks like beneath the smog because Cassini did not go to Saturn alone. It carried a passenger, a smaller blind machine named Huygens, bolted to its side. When we reached Titan, we detached Huygens and pushed it into the atmosphere. For 3 weeks, the smaller probe fell silently through the dark, completely asleep, coasting toward a world we couldn't see. When it hit the upper atmosphere, it woke up, deployed a parachute, and descended blindly into the orange abyss. The cameras captured the descent. It fell through thick methane clouds. It saw jagged mountains made of frozen water, carved by rivers of liquid hydrocarbons. And then, it hit the ground. Huygens survived the impact. It sat alone on a freezing alien floodplain, littered with rounded icy cobblestones, and it transmitted data back up to Cassini for exactly 72 minutes. And then, its batteries died. We flew on, leaving our passenger behind in the freezing dark, sitting on a toxic beach, never to be retrieved. But Titan was not the discovery that would seal Cassini's fate. That discovery belonged to Enceladus. Enceladus is tiny, a blindingly white sphere of ice, barely 300 miles across. It should have been a dead, frozen rock. But as our cameras flew past, we saw something impossible. The moon was erupting. Massive plumes of water vapor and ice particles were blasting out of deep fractures at the moon's south pole, shooting hundreds of miles into space at supersonic speeds. We did not just take pictures. We did something incredibly brave. We altered Cassini's course, and we flew it directly through the plumes. We tasted the water. And the data we sent back changed the course of human history. Beneath the miles of frozen ice, Enceladus is hiding a global, liquid saltwater ocean. And at the bottom of that dark alien ocean, there are hydrothermal vents, heat, energy, complex organic molecules. It has many of the essential ingredients required to support life. In the freezing radioactive dark of the outer solar system, orbiting a violent gas giant, we found a warm, salty ocean. It was the greatest discovery of the mission, and it was the exact reason Cassini had to die. But before the end, we had one last mystery to map. We looked down at Saturn's North Pole, and we found something that broke the minds of the people watching from Earth. Nature does not draw straight lines. Physics prefers spheres and circles and chaotic swirling spirals. But raging at the top of Saturn is a perfectly geometric, six-sided storm, the Hexagon. If you were to hover above Saturn's North Pole and look down, you would see it directly beneath you, 20,000 miles wide enough to swallow the Earth twice over, with room to spare. Walls of 200-mile-an-hour wind, holding straight lines that nature is not supposed to draw. And at the dead center, a single massive hurricane eye, staring straight back up at you, into the void where you are floating. It is an atmospheric standing wave, a fluid dynamics nightmare on a planetary scale. There is something profoundly unsettling about looking at a gas giant and seeing perfect geometry. It implies a mechanical precision that shouldn't exist in nature. It looks like the machinery of a god. We stared into the Hexagon, taking the highest resolution images ever captured. But our machine's time was running out. By 2017, Cassini had been in space for 20 years. We had spent 13 of them orbiting Saturn. The maneuvering propellant was running critically low. Soon, our proxy would lose the ability to steer. It would become a dead 6-ton piece of radioactive metal, drifting blindly through the Saturnian system. And that was a problem. We had discovered the underground ocean of Enceladus. We had proven that life could potentially exist in the dark. If a dead, drifting Cassini were to eventually crash into Enceladus, it could introduce Earth microbes, stowaways that survived the vacuum of space, into that pristine alien ocean. We could contaminate one of the most promising ocean worlds we had ever found. NASA realized they could not allow the machine to drift. They had to execute it. They called it the grand finale. Cassini was commanded to do something it was never designed for. It was ordered to dive directly into the narrow, terrifying gap between the innermost rings and the upper atmosphere of the planet. Between the innermost edge of the rings and the upper atmosphere of the planet, there is a gap, a corridor of space roughly 1,200 miles wide. Before 2017, nothing had ever flown through it. We called it the Big Empty. But at 40,000 miles per hour, empty is a relative term. If there were stray pieces of ice in that gap, even a particle the size of a grain of sand, it would hit Cassini with the kinetic energy of a sniper bullet. It would instantly cripple the machine. The engineers at NASA pointed Cassini's main dish-shaped antenna forward, using it as a physical shield, a makeshift battering ram to take the micro-impacts as it plunged into the corridor. When Cassini emerged from the other side of the first dive, it turned its antenna back to Earth and sent the data. The audio captured by its radioplasma instruments was shocking. It wasn't the sound of a hailstorm. It was the sound of absolute emptiness. The gap was pristine. For 22 weeks, we threaded this needle, diving down through the gap, grazing the upper atmosphere of the planet, soaring back up over the rings, and diving again. Each orbit brought it a few miles closer to the ammonia clouds. Each dive pulled it deeper into the gravity well. It was a slow, calculated surrender. And on September 15th, 2017, it began its final descent. We hit the atmosphere of Saturn at 77,000 miles per hour. At that speed, the friction of the hydrogen gas is like hitting a brick wall. Our machine began to burn. The outer insulation melted. The structural frame began to bend. But Cassini was our engineering, and it did exactly what we built it to do. As it fell into the crushing pressure, tearing itself apart in the violent winds, it fired its remaining thrusters to keep its antenna, our last thread to it, pointed perfectly at Earth. It kept its eyes open. It kept its mouth speaking, transmitting the atmospheric data back home in real time, fighting the planet for every single second of survival, sending us everything it could until there was nothing left to send, until the thrusters could no longer fight the aerodynamic drag. The probe tumbled, the antenna turned away from Earth, and Cassini was crushed, melted, and completely absorbed into the planet it had spent its life studying. But the tragedy of the longest goodbye is the math. Saturn is nearly 1 billion miles away from Earth. Even traveling at the speed of light, a radio signal takes 83 minutes to cross that distance. When the engineers at NASA received the final ping, when they watched the telemetry flatline and knew the machine was gone, they were looking at a ghost. Cassini had already been dead for 1 hour and 23 minutes. We watched it fight. We watched it fall. But by the time the light reached us, it was already part of the storm. We sent a machine into the dark to show us the monsters. And when it was done, it stayed there. A silent, invisible fraction of a golden giant, turning quietly in the black.